Hello there. This is Matz, the creator of the Ruby language. I'm very glad to be here at the RubyConf China so that we can help you. I can give a presentation to the audience. Today, I am going to talk about the Beyond Ruby 3.0. The Ruby 3 was finally released on last Christmas. We have talked about the Ruby 3 for a long time, about improving the performance, adding new features, and a lot of things. And it was finally released. The major goals of the Ruby 3 release was the being compatible and being faster and being better. So first, I'm going to talk about the compatibility. Well, for Ruby 3.0, almost all 2.x programs run on Ruby 3.0 without any modification. So that we try to keep the compatibility. Because the compatibility matters. So we have learned the lesson that once upon a time, maybe more than 15 years ago, we released the Ruby 1.9. And then when we released the Ruby 1.9, we had to introduce some incompatibility. For example, we have to change the encoding support for the better Unicode handling, and then we have introduced a new virtual machine. So that is required because of the language had to be evolved. But some people stayed using the older version 1.8 for a long time. We suffered some kind of the community split for more than 5 years. Some people stay using the Ruby 1.8, and some people start using Ruby 1.9 and 2.0, and that kind of things is kind of a tragedy, I think, because we core team improved the newer version 1.9, 2.0, and then we added new things, and then we improved the performance a lot. But those kind of new technology and new features did not reach to the conservative people, like people people kept using Ruby 1.8, and that is tragedy. And that kind of tragedy can happen in other language. And we saw some kind of similar situations for other languages. For example, the Python 3. Python 3 had some compatibility issues from Python 2. So there are some people that kept using Python 2 for a long time. The Python community suffered similar community split for more than 10 years. And in the PHP community, they try to introduce the drastic changes in PHP 6 from PHP 5. And that kind of change was too incompatible and too drastic. So the most of the community did not want to follow the newer version. So the PHP 6 was cancelled, and then they started all over from started PHP 7 out of PHP 5. The similar things happened in the ECMAScript 4. The JavaScript community didn't want to follow the ECMAScript 4 standard, so the ECMAScript 4 was cancelled, and then they started the ECMAScript 5 out of ECMAScript 3. The ECMAScript 4 was introduced the classes and many other very drastic changes, and those most of the changes are gradually introduced in the ECMAScript 5 and ECMAScript 6, and then but ECMAScript 4 was too drastic, so that people didn't want to break the compatibility. Yeah, we language designers make mistakes, and we want to fix those mistakes if we could have chances, and we have some regrets in the language design. Even Ruby has some kind of the drawbacks and the weak points and the mistakes in the design in the past. And the major version upgrades like the Ruby 2.0 and Ruby 3.0 is the great chance to fix those mistakes. And it was pretty tempting for us language designers to fix those mistakes. But as a result, we probably satisfied. But the people don't get much benefit out of those kind of changes. Those changes introduce the incompatibility, so that people need the force to fix their programs. That kind of incompatibility is pretty bad. So that's the difference between applications and languages. In some upgrades, the applications, the design of the application, behavior of the application may change. But we users can easily adapt to the new behavior and the new design. But for languages, the programs written in that language do not follow automatically. So that the programmers need to change, update the existing programs to follow the newer version of the language. That is kind of pain. The programmers love new things. Yeah, we love new things. We love new technologies. We love new languages. We love new language features. But at the same time, we don't want to be forced to change of our software. The major version seems to be a chance to fix those mistakes in the past, and a great chance to change, but it is great chance to break existing programs. That means the programmers hate pain forced by new things. So that, we love new things, but at the same time, we can hate new things, or at least we hate pains forced from new things. That is the reason the compatibility matters. We have learned the lesson when we released the Ruby 1.9 that we need to make progress without breaking the past. So that I am not going to change the language to make it, simpler or fix the past mistake. Okay. But we will improve the language, carrying compatibility. We should keep compatibility, so that we try to keep full compatibility. So that of course, language should evolve, it should be improved, so that we have to add new features. But the new features must have done keeping compatibility, except for a few bug fixes. So that, some programs can rely on buggy behavior. So that, unfortunately, we have to ask users, programmers, to fix those programs relying on the buggy behavior. But except for those small exceptions, that we try to keep full compatibility. So the compatibility matters. The second things, performance matters too. That's why we have introduced the JIT compiler, just-in-time compiler. The just-in-time compiler generates the native code dynamically. So that since Ruby 2.6, we have introduced something named the MJIT. MJIT is the short for the method JIT, and it generates the native code inside of the virtual machine. To achieve the goal of the Ruby 3x3, that means the Ruby 3 runs 3 times faster compared to the Ruby 2. So the Ruby 3 runs 3 times faster in some benchmarks, especially Optocalot. Optocalot is the Nintendo Entertainment System emulator, so that it runs the NES games, and it runs almost 3 times faster compared to the running on the Ruby 2.0. But unfortunately, the Rails application is too big and too complex to improve the performance. As of Ruby 3.0, the Rails applications does not run slower using the JIT compiler. In the past, for example, on the Ruby 2.6, Rails application runs 2 times slower using JIT compiler. And compared to that, the current situation is the huge improvement, but not satisfactory. So that we are going to improve even further in the coming releases after 2.0. We are improving. I will talk about the performance improvement later. Then concurrency. So to improve the performance, we also added the concurrency to the runtime. I started developing Ruby in 1993. So that it was 28 years ago? Whoa. Time flies. And at that time, most of the computers have only one CPU per computers. So that we don't have to worry about the multi-cores back then, 1993. But I added threads to the language to implement some kind of the software architecture easier. For example, the producer-consumer model, or some kind of the publisher-subscriber model. Those models can be implemented easier using threads. So that's the reason I implemented the threads to the language. But back then, people don't expect performance improvement using threads, because now the threads is fundamentally makes programs run slower because of the time slicing. But now, currently, we have a lot of codes. Our PC has dual core or octa core or 64 cores or even more cores. We have a lot of cores on the computer. So that to present day, we use more cores to improve the performance. So that use more cores, your software run faster. So that to improve the performance today, the concurrency is the key. But we have Gale, which is the giant interpreter lock, which prevent the multi-threads runs asynchronously. Because of the thread safe runtimes is hard. Especially hard for existing languages. So that it's if the virtual machine is written in the concurrency in mind, the thread safe the virtual machine, implementing thread safe in the virtual machine is extremely difficult. And then if we remove the GIL from the virtual machine, your program will crash as soon as you spawn the new thread. That's not good. That's not good. So we had to add new concurrency model to the language to improve the situation. Our ideas are, one is the async fiber, the second is Raptor. The async fiber is to improve the I/O multitasking, I/O multiplexing, and then the second one, Raptor, is the better, more abstract the concurrency model. The async fiber is designed for I/O heavy tasks. Now, it's kind of like an async and await in other languages, like PHP, Python, JavaScript, C#, or Node.js. In Ruby 3, instead of adding the async and await, we use fibers. We don't have to add new keywords to the language. Just we add the switch context on I/O operations. If we specify the scheduler. Async fiber, you have to know that the async fiber does not use the multi-core, but it provides the faster context switching that results in the faster performance. Yeah, for example, the Node.js is known to be fast JavaScript virtual machine, and it does not use the multi-cores, but it uses the asynchronous model for the I/O operations and the other the other system codes. So that kind of multiplicity makes Node.js faster. Basically, our async fiber is based on the Falcon application server. In fact, the chief architect of that async fiber is the Samuel Williams, who is the author of the Falcon web application server. So then, how can we use multi-core? Since async fiber doesn't use the multi-core, so that we have to need something new to use the multi-core. So for CPU intensive tasks, we introduced the Raptors. Raptor stands for Ruby Actors. Yeah, it's designed for for CPU intensive tasks. It's kind of like an isolated object spaces to communicate, does communication via channels. So that basically it does not share state. So that you don't have to worry about the conflict or the deadlock or anything like that. In fact, it does use the limited sharing between data sharing between Raptors. First, immutable objects, for example, numbers and symbols, and those immutable objects can be shared between Raptors because it doesn't change the state, so that you don't have to worry about the sharing the states. And then the second, recursively frozen objects. We call them the deep frozen object. Can be shared, and then it doesn't have states, so that you cannot be change the deeply frozen object, so that you don't have to worry about the state. The third one is a little bit tricky, and you can share the classes and the modules between Raptors. So that in Ruby, classes and the modules are mutable, so that you can add new constants or the instance variables, the classes and modules, so that when you access to those classes and modules, the Ruby uses some kind of the internal the mutual locks, exclusive locks. Except that we don't have the GIL between Raptors. So that means that you can easily utilize multi-core using Raptors. This is a small example of Raptor programming. The Tarai is the recursive benchmark programs. And when the first one, the first sequential version is the call Tarai function 4 times. And the second parallel version kicks the 4 Raptors and then take the value out of those Raptors. Then in this benchmarks, that runs 3.6 times faster than sequential version. Not 4 times because of the we need to some kind of the memory management costs and the communication costs or something like that. But 3.6 times faster is not that bad. Yeah, that we are working on improving the performance too. Third things, okay. Compatibility, performance, and language improvement. For Ruby 3, we improved the language a bit. For example, error bug finding. So it's the current today is the age of static typing. The popular language like Go, Rust, Swift are the static typed programming languages. And then the dynamic programming language like PHP, Python, JavaScript are, enhanced to support some kind of static typing. For example, the PHP added type declaration to the language, and the Python added type annotation to the language, but not static type checking. And the TypeScript is the statically typed version of dialect of the JavaScript. So that it seems that everyone goes static typing. Yeah, the static typing is pretty popular, and everyone seems to go static typing. the question is, shall we do that too? Shall we go to the static typing camp as well? My opinion is no. We don't want type declaration to the language. We don't want type annotations to the language. But at the same times, we realize the benefit of static type checking. We want more precise checks. And we want to detect more errors earlier. And we want more precise, extensive code completion. So that's the reason we added several tools to add static typing to the language. We are not going to change the syntax, but we added several tools to support static type checking. The first one is the Ruby signature. The second is typeprof, and the third one's the static type checkers. The Ruby signature RBS is some kind of the language that describes the static type of the Ruby programs. It's kind of like the D.TS counterpart to of the TypeScript. This is some example of the Ruby signature. It defines there is class foo, has two methods, which one is foo, takes no arguments, then returns void value. And the second method is 2s, that takes no argument and then returns strings. And then 2s may take integer and then returns strings. Yeah, this is Ruby-like, but it is specialized to describe the static types of the software. And then Ruby 3 ships with the Ruby signature for the standard libraries. So that you can use the static type information of the built-in libraries. Then type checkers. So that by using those informations, you can implement the type checkers, then the better IDE, better code completions, or maybe the type signature pop-up, so that those kind of information can improve the experience from the tools that support the Ruby programs, like IDEs or the formatters and the code completions or many things. The second tool to the signature is the typeprof. Typeprof does the naive type checks and the signature generation from your applications. It is the technology named abstract interpretations. Yeah, well, this is the kind of the silly Ruby programs, like a class foo has two methods, foo and bar, and that takes one argument, and then bar takes one argument and returns b, and then foo is called with the integer. That means the a argument in the foo method must be integer. Then integer plus 2 makes integer, so that means the method foo should return integer. The method bar was called with 42. The a argument of the method bar should be integer, but there's no method, no plus method that takes integer and the strings. That is the type error. So that the typeprof raises error that you cannot estimate the correct static types for the method bar. As a result, this is abstract interpretation. As a result, the type prof generates this signature. The class foo has the method named foo that takes integer and returns integer, but method bar does not have the correct types, so that it just generates, just ignores the existing of the method bar. So by using those tools, you can improve the experience of the Ruby programs, like statically typed programming language, like a TypeScript and a C# or whatever. And then to tell the truth, I'm not fully satisfied with the current experience out of those tools yet, but we are working on them so to improve the experience. The type prof should run faster and find more errors, and we will try to improve those things for the better Ruby experiences. And we want even better Ruby. We added several new syntaxes. For example, the pattern matching and the numbered parameters. Yeah, we have added the pattern matching in 2.7, but that was the experimental state. And after experimenting a bit, so that we finally release pattern matching as the final state. This is an example of the pattern matching. So that the JSON parse returns some kind of the JSON data, and if the person has the name Alice, who has the children named Bob, and the print age of Bob, and if you don't find Alice, just print no Alice. This is much easier to take the value and check the name equal Alice, then find a child named Bob and take age out of them. So that this is more declarative and easy to understand, easy to write. And then you can write a one-line pattern matching as well, as an assignment, as a multi-assignment or decomposition. And you can use it as a decomposition of the hashes. Also, we have added the numbered block parameters like this, so that except for the instead of writing the bar X or something like that, so that you can just under bar 1 or something like that. For shorter blocks, it's much easier than the readable. But don't use them for the big blocks, because it can be used your program more cryptic. That it is for the short blocks, shorthand for the smaller blocks. Okay, this is Ruby 3.0. Ruby 3.0 is a great release, and we are working on improving it, but I'm pretty much satisfactory about the status of the Ruby 3 in general. We have more rooms to improve them, so that after Ruby 3.0, so we are working on making them complete. Some new features may be buggy, especially raptors, so that we need improvement. But generally, Ruby 3.1, we are planning to release it on the next Christmas. That will be more conservative release, so that we add less features than compared to the Ruby 3.0. and it should be more stable and less bugs. You will suffer less bugs. And in general, after Ruby 3.0, I think we will have some kind of moratorium to the language enhancement. So that we are focusing more on improving tools, supporting tools. Remember that the Ruby static typing is supported by tools, not the language enhancement. For example, adding the type declaration to the language. So the tools can improve the Ruby programming experiences. And then I believe the tools are more important today. For example, we have the Solar Graph, which is the language server protocol server. And then we have Solve, which is the very fast static type checker for Ruby. And we have RubyConf for the linter and the bug fix, some kind of bug fix, and the code standard enforcing. Those tools teach us better tools, enables better user experiences. We need more tools. We need more better tools. We need type checkers like TypeProf, or we need a formatter like a RuFlow, a language server protocol server, and then we need to improve the Solar Graph, and we need performance tuning tools. We need better debugger or something like that. So that we encourage community to provide or improve the supporting tools that can improve the experiences of Ruby programmers. And we also encourage community and core teams to improve the performance. Ruby is fundamentally a human-oriented programming. So that in the history of the Ruby language, the performance is not the first priority in the Ruby design and implementations. But still, performance matters. Remember the Ruby 1.9 tragedy. Ruby 1.9 was released in 2007. And then we introduced the incompatibility. As I told you, we had issues in encoding. And then we have added the new virtual machine. And then some refused to migrate to 1.9. Then community split for 5 plus years. And then Ruby 2.0 was released in 2013. So that then the whole community was gradually migrate to the newer version, the leaving 1.8. That kind of 5 plus years community split is a tragedy, but compared to the Python community, the Python community's problem was the Python community suffers longer. The Python 3 was released in 2008, and Python 3, this is not wrong. Python 2 died in 2020, last year. And then it's more than 10 years to migrate to Python 3. The community split for the more than 10 years. That is even more tragic. We have suffered 5 years, and they have suffered 10 years. And then what's the difference? I believe the difference is we have new virtual machines. The new virtual machine was far faster than the previous ones. The 1.9, I mean 1.8. So our developers are willing to pay the price of migration because of by migrating to the the newer version, your programs will run faster several times. They didn't want to upgrade their software for cleaner languages. That's not the clear benefit. But for faster language, they are willing to pay the price of migration. That performance matters. That's the reason performance matters. Performance heals problems, and performance forms reputations. You love performance comparison. We love performance comparison. But how we measure those performance? Yeah, programming language has many aspects. You cannot assume how they are used. The Ruby can be used in the web applications. Ruby can be used as the admin tools, the command line tools, and the GUI applications, and the games, whatever. And then, yeah, or even in the scientific computing. But how we measure those performance? Unfortunately, we measure performance of the language by micro benchmarks, like calculating factorial numbers or Fibonacci numbers or word counting from the text. Are they related to real world performance? I don't think so. It's quite fun story for the the chit chat, but people make decisions on the false assumptions. Okay, this programming language is 2 times faster in word counting, so let's choose this language for our web applications or something like that. That's kind of silly. But still, the performance forms reputations. The Ruby is fast enough for most of the cases. GitHub runs on the Ruby, and Shopify runs on Ruby. Instacart is running on Ruby, but the people claims Ruby is slow from the result of the micro benchmarks. The micro benchmarks forms reputations. Okay. We will improve the performance, not only for real world applications, but for micro benchmarks too. Because people trust micro benchmarks. Yeah, for your information, the Python community come to similar conclusions that they try to implement the faster C Python, and then they try to make C Python faster, and then Shannon Plan is making Ruby 5 times faster in 4 times. So 1.50% faster each year. And then, they are working on the open discussions and the open source. And then they try to improve the performance. Like this. Python tries to run 5 times faster in 4 years, and then 50 times faster each 4 years. 1.5 powers to 4 makes the 5.0625. By using the technology like adaptive bytecode interpreter, beta frame stacks, and zero overhead exception, faster integer internal, just-in-time compiler. Some of them have already done in Ruby 3, the box integer, and the beta frame stacks, and the support operators, JIT compilers. And then, frankly, I'm suspicious about the estimation of the making Python 5 times faster in 4 years. But but I will be happy if I prove wrong, and if I'm planning to steal the ideas to improve the performance of Ruby as well, and we will try to improve the performance too. Anyway, probably we are trying to Ruby 3.3 revisit. Ruby 3.x will be 3 times faster than Ruby 3.1. Yeah, this is just idea. No concrete estimation. No concrete ideas. But at least we try to improve. Continue improvement. We try to implement the better jet. For example, adding the lightweight jet on top of the MJet. Yeah, the two projects is working on. Which one is the Mio from the blood Makarov, who is the original author of the MJet, and also the from Shopify, we have some kind of the fork of the Ruby virtual machine implemented the YJet, and after that we might implement the multi-layer jet. Also, we are going to improve the performance of the reactors, like the N reactors on top of the M native threads. So that should be more lightweight than the current one-on-one reactors. We are not going to see much language enhancement in the near future. But our big idea for the next language enhancement will be the beta packaging and the code attribute. The beta packaging is in Ruby, require has no isolations, But a package like a Java Python, isolating constants and the variable namespaces, and it is still big ideas, but we can implement that kind of things to the Ruby as well for the beta packaging. The code attribute is kind of the simpler metaprogramming. This is example, not concrete example, but just idea. But sharp bracket frozen makes class frozen, and sharp bracket private makes method private, or something like that. Yeah, this is ideas for the future, but not in the near future. We are working on right now. We are working on improved existing implementations. But yeah, we as a language designers, I still thinking about the new ideas and the language enhancement. Anyway, we will keep moving forward because as an open source community, we have to keep moving forward. And then, as we have already tried to improve the language and to change the language, and then to provide a better experience in Ruby programming, because I want to help you creating better world. So that I implemented and I improved Ruby to create a better world. And as a Ruby programmer, you create your software, probably using Ruby, and you will create the better world. I thank you. Bye bye. Yeah. And yeah, I hope someday I can see you face to face, physically. Yeah. But until then, see you. Bye.